Today we're going to write equations for ellipses. They're all going to be centered at 0, 0. So we have to understand all the different parts. We have two diagrams and two formulas because some of the info is for horizontal and the other is for when they're vertical. So we have to know what the major axis is. The major axis, depending on the way it's turned, is the longer one. So in the horizontal one, the major axis is the x-axis. And in the vertical ones, the major axis is the y-axis. The minor axis is the shorter one. So the minor axis for horizontal is the y-axis, and in the vertical it's the x-axis. Now we need to know what the vertex, the covertex, and the focus are, and we're going to give them each a letter. The vertex is the most important of the points because it's on the major axis. It's a big deal. And it's where the ellipse crosses the major axis. So right there and right there. Since the ellipse is centered, the distance away from 0 is either a or negative a. And we're always going to work with positive a when we talk about where the vertex is. So it's right there if we have a horizontal, or the vertex is right there or right there if we have a vertical ellipse. You can put on the major axis. All right, less of a big deal is the covertex. It's like the sidekick vertex. It's not as important. We use the letter B, and it's right here for a horizontal one, or right here and right here. It's on the minor axis. And the last thing we need is this thing called the focus. The focus is on the major axis. It's on the major. It's inside the ellipse. See that blue dot there and there? And it has to do with how we draw the ellipse. If you were to connect the two focus points to the outside of the circle with a string like this, you could drag the string all the way around in a loop with a pencil, and it would draw the ellipse for you. So that's where they come from. There's a formula to get them, but we aren't going to deal with that. All you need to know is that we use the letter C for focus. I remember it's letter C because focus has the letter C in it. And it's on the major axis. So in the vertical one, they're right there and right there. If you click on the link right here for foci, that's plural for focus. If you click on that link, you can see a video of an ellipse being drawn, like the way I was describing. So here are the two formulas. We have the horizontal formula and the vertical one. These are all centered at 0, 0. And let's take a look at the difference between the two equations. We have x squareds and y squareds, a squareds and b squareds, and they all equal 1. So the only difference between the two is, see in this one the x squared is written first, and in this one the y squared is written first. They do that for the formula, but you have to be careful because they don't always do that in the homework problems. The way you can for sure tell which is which is horizontal ellipses have a longer major axis, right? So since A goes on the major axis, A is the biggest number. Biggest number. Oops. In the vertical ellipses, since the vertical axis, the y-axis, is the major axis, then A is your biggest number in that. So it's under the y squared. Biggest. All right. The rest of this information gives you the coordinates of where each of those three items are that we just talked about. So you can see that we really only need A and B in order to write the formula. Sometimes you're given A and B and life is good. If you're given the vertex and the covertex, it's good. But sometimes they give you A and C or B and C. And so sometimes you're going to have to use that formula to solve for what you need. You only need A and B for the formulas. So let's try these. The first example has been drawn for us, so it's really easy to tell by looking at the picture that we have a horizontal ellipse, which means we're going to use the equation in the horizontal column. Now let's figure out if we have the vertex, covertex, or the focus. So I'm going to just label. Since this point right here is on the major axis, that tells us that the number right here, that -10, is A. Over here on the other side would be the other vertex, and it would be at +10. So we're going to go ahead and use A as +10. Now they came out and said right here that the focus is 8. So that is our letter C. C is 8. So we know A is 10, we know C is 8, but what we need is we need to figure out what B equals. So let's plug our information into that equation. C squared, so 8 squared, equals A squared, 10 squared, minus what we're looking for, B squared. So we're going to solve this. So we need to get the B all by itself. We're going to square the numbers first, then get rid of the 100 by subtracting it. That will leave us with -36 equals -B squared. Let's cancel out those negatives. I'm just going to flip them both to positive. Now we can square root, and we get B equals ±6. In this picture, it means that right here would be -6, and right here, the covertex, would be +6. But now that we have A and B, we can write the equation. We are going to, if we follow the formula up there, write down the x squared first. Underneath it, we'll put A squared. So A is 10. We're going to put 10 squared plus y squared over B squared. B, we just figured out, was ±6. So it's going to be 6 squared, and that equals 1. When we simplify that a little more, it's going to be x squared over 100 plus y squared over 36 equals 1. I know it's kind of scrunched up, but that's the answer. I'm going to try to fit 1b in this space right here that I have left. So I'm going to look at this, and I see I have an ellipse with the vertex 0, 8. The vertex, remember, we use the letter A to label. So we know so far that A equals 8. And the covertex is 3, 0. The covertex, remember, we use the letter B. So B equals 3. We're pretty much set to plug it into the formula. We just need to know which way to write it. Do we write it using the horizontal way or the vertical way? Well, we could draw the ellipse. You know I like graphing. So we could plot the point 0, 8, 0 over 8 up, and 0 over 8 down, and then 3 over 0 up, so not that far away, and we can see that that's a vertical ellipse. If you don't like sketching the graphs, you can always match up your points with what you see in the formula table. So we would look at the vertex row, and we'd find the ordered pair that has 0 first, and then the 8 in the y position. So that matches up with this type right here. So we can confirm it's vertical. So let's go ahead and write the y squared over our a squared, which is 8 squared plus x squared over b squared, so 3 squared, that equals 1. And then the last step is to simplify. So our answer will be y squared over 64 plus x squared over 9 equals 1. So that's our final answer. All right, let's graph these. Let's take a look at these numbers. We have x squared over 169 and y squared over 25. So what's going to happen is we are going to solve for a and b and plot the points. So a squared is underneath the x squared. So I'm going to write a squared right here. And b squared is underneath the y, so I'm going to write b squared right there. And I'm going to solve. I'm going to solve a squared equals 169. I'll square root both sides and get a equals plus or minus 13. So we're going to go on the x-axis, because it was underneath the x, we're going to go to the right 13 and to the left 13. Now we'll solve for b. B squared equals 25. So we'll square root both sides, and we're going to get b equals plus or minus 5. So we're going to go up and down 5 on the y-axis because that number was below the y. So we'll put a dot right there, put a dot down there, and the last step would be to connect your dots with the best looking ellipse that you can. Alright, now for 2b. Now the y squared is first, so we have a squared underneath that, and we have the b squared right here. And now we just need to solve. If we square root and square root, we get a equals plus or minus 12. And then when we solve for b, when we square root, we get b equals plus or minus 3. So let's plot these points. Where are we going to plot the 12? We're going to plot it on the y-axis. So let's go up 12 and down 12. And now we're going to plot the 3. Those will go on the x-axis because they were under the x. So there's our dots. We can see this is vertical, and we will connect them like that. Now that I've shown you how to do those notes the way the book showed us with the formulas, I sort of need to point something out. If you follow the book's formulas, they always have the y squared going first if that's the major axis. That might not always be the case. A better way to tell, now that we've learned everything, a better way to tell which axis is the major axis is whichever letter the bigger number is underneath. The bigger number is the major axis. That'll be the longer axis. So if you look at number 8, see if you were to square root the 36, you'd get plus or minus 6. And if you square root the 81, you'd get plus or minus 9. The 6 would go on the x-axis. So right here and right here. And the 9 would go on the y-axis right there and down there. And you can see that this ellipse is vertical, even though the y squared wasn't first. So an easier way to keep track of things is whichever the bigger number is under. Bigger number is under the major axis. Alright, that might help clear up some of the homework problems.